So welcome everyone to the fourth installment of our webinar series. Today we've got Colin Keogh with us, who's going to be talking about low tech for high impact, applied technologies for local resilience. So some of you may be familiar with Colin and his work to date. We're delighted to have him here with us today, sharing his knowledge and expertise. So for those of you who don't know, Colin is a mechanical and innovation engineer and engineering researcher, and he has co-founded the Rapid Foundation, Sapien Innovation, and Team OSV. So at Sapien Innovation, he delivers design thinking, creativity, and innovation workshops to different audiences. And the Rapid Foundation aims to empower people by putting disruptive technologies in their own hands so they can solve their own problems. Team OSV was obviously set up in March earlier this year and to provide open source solutions for the needs that emerged in the COVID-19 pandemic. Colin is also an Irish Research Council Scholar, and he was selected by Forbes as one of the 30 under 30 in the category of science and healthcare. So as I say, delighted to have Colin here today to share his insight and expertise. We will have a short Q&A at the end of the webinar as always. So if you want to just write in the chat box or Q&A that you have a question, and I'll unmute you so that you can ask Colin. Okay, so guys, enjoy the webinar. I'll pass on over to Colin now. Thanks, Colin.
Thank you very much. Hello. Into the ether. Hello, I hope you're all well. Thank you very much to EWB and Emma and for asking me to come and talk today. So yes, I'm going to talk a little bit as part of the resilience series. I'm going to talk a little bit about low technology for high impact. So my background is an engineer, and we'll get into that a little bit. What I'm basically going to do over the course of the next half an hour or so is show experiences from my own kind of work and background and other projects and other ideas that are in this space of how you can use what is considered low technology. It may be quite high tech, but it's low price technology to achieve quite impactful and high impact in the world as a whole, and to tackle some kind of large global challenges all around the world and in loads of different fields. So yes, that's what we're going to talk about. That's me. So a little bit of a framing. I start all my talks the same way. So I was a born engineer in effect. My father was runs a small car mechanics garage out in Bray in Wicklow. And ever since I was a kid, I was involved with him, fixing cars, mending cars, like identifying problems. I was always very practical. I was one of them Lego kids. So I love taking things apart, putting it back together. So in an awful lot of ways, I was kind of a born engineer. And I followed that on into UCD and did mechanical engineering, specialized in renewable energy systems. And then I've just finished a PhD on innovation methods. And I've been working in the kind of intersect between engineering, technology, innovation, and how it applies to any field in general. I'm quite a generalist, so I will work in any field, in any space, with any company. I love looking for problems and challenges and issues in fields that I know very little about, because that's where the learning and that's where the good challenges are. But in effect, I'm very kind of different. I have a different approach to an awful lot of engineers. I am a grown-up child in effect, so you know, I like to everything I do is applied. I like to do applied everything. Theory is well and good, but it's not proven until you actually apply it in practice. So whether it's physics lessons with giant catapults or kind of optimizing fuel systems with actual kind of real cars, applications and applied work is kind of what I love. So what I'm going to talk a little bit about is technology and how you can apply it. So technology is a very, very broad word. So what I'm going to do is talk about it and how it affects the world around us and what you can do with it. But a very important caveat that I always put in is technology and is only a tool. Technology is a tool, regardless whether it's a VR system, an advanced manufacturing process, AI, 3D printing, no matter how complicated it is, it still is a tool. It's designed to help you solve a problem or do something with it. So you actually need to use it for it to have an awful lot to have an impact in the world around you. So buying it and then not doing anything with it will not solve your problem. It will not solve the problem on its own. You need to use technology for something in particular. And then I thought the best way to kind of do that is to talk about 4 individual stories based on the work that I've done in the past and I'm currently doing, based on split between the kind of 4 different activities that I'm kind of working on over the last couple of months to explain how you can use kind of low cost but high impact technologies to solve these complex problems. So the first one I'm going to talk a little bit about is a project based around the work I do in UCD. So as I said, I'm a research engineer in UCD. and I look at applying technology to a whole range of different products from a kind of academic and a research level. So I've worked on a range of different R&D projects: renewable energy, community co-design and resilience, marine waste. That sort of stuff is trying to find and apply new technology interventions that can help tackle these kind of large global problems. I'll use another one from the work that I do at Sapien, which, as Emmett said again, is an innovation consultancy, and we do workshops, training, and work with companies, government bodies, European institutions, whatever it may be, and we help them improve their innovation potential. We run hackathons, we do refined innovation plans, we help them add that kind of dynamic of innovation to their current and future activities, and we've done that with a range of different companies over the years. I'll then use another story from my work with the Rapid Foundation, when we use 3D printing to do overseas and humanitarian developmental work using 3D printers. And then the final one I'll talk about is our activities with Team OSV and our interventions as it relates to COVID. So technology, in effect, has never been cheaper when you're considering consumer technology. So as you see in this graph here from Business Insider, you know, things like televisions, personal computers, computer software, audio equipment, a huge amount of electronics. Since the kind of late 90s, early 2000s, the price of them has just dropped to very, very minuscule amounts in comparison to what they used to be. For a couple of €100, you can buy a high performance computer. You know, everyone is walking around with a supercomputer in their pocket in the form of a mobile phone. You have HD cameras, you have connected internet, you have anything and everything. So consumer technology is ubiquitous. It's spread all around the world. It is in locations you'd never imagine, and it can act as a tool to generate more impact and make a kind of more meaningful difference in the world by accessing the technology that is distributed around the world already and using it for something kind of useful. But as I kind of said before, it's only a tool. So I kind of like this image here, you know, new, fancy, high tech, these solutions and technologies come along every day. There's the next generation of something, but it needs to be used. You need to do something with it. There's always an Achilles heel into it. It is not the solution to the problem. This is a tool to allow you to get to that. So you need to apply it. You may apply it and break it. You may apply it and it might not work the way it's meant to. You may apply it and you find out you need something completely different, but you need to apply it to find out these lessons going forward. The third story I'm going to talk a little bit about is some of the work that I do as a researcher. So my background is in engineering, as I said, and the work I've done the last kind of 3 years for my PhD has been based around innovation methodologies, creating new designs and structures to help people innovate and be more creative without the need for an expert to be involved in the process as much as possible. So, you know, you might be familiar with concepts such as design thinking and that sort of stuff. These are processes and guides that help people be more innovative and help guide them on a process. So there's a difference. An awful lot of people are linear and they like rules to follow and structures in order to help them be creative, which is all well and good, but you don't want to create a structure which constrains their creativity too much, because then you're not being innovative. So these sort of kind of design thinking methods and workshops, these kind of help you put some sort of order on your creative thinking and help people from more technical backgrounds develop and be more open and innovative and creative. So, as I've said numerous times, technology is just a tool. What matters most is how you use it. So the first story I think I'm going to talk about is some of the work that I do based in UCD. And we looked at enablers. So what is the biggest technology enabler you could have when it comes to trying to develop and create impact in the world? And that enabler is the mobile phone. So the mobile phone is now ubiquitous. You will find them absolutely everywhere. They provide 99% of the services and technologies you could ever imagine. High-speed internet in an awful lot of places, instant connectivity, you know, super powerful processors, multi-scope cameras, 3D scanners. Anything and everything is based out of the mobile phone. And it's been integrated and used for kind of high-impact work around the world. So, you know, for, you know, couple of €100, you can buy what is in effect a supercomputer that will connect you to all the information you need and provide 99% of the technology tools you could possibly want for any sort of intervention project you could imagine. So just as a list of examples, you can buy external accessories for your mobile phone to turn it into an advanced digital stethoscope. You can measure heart traces, you can measure pulses, you can measure breathing rates, you can measure an awful lot, and then remote send the information to a healthcare professional who could be thousands of miles away, ideal for rural and remote locations. Similarly, a simple kind of couple of $100 attachment can turn your mobile phone into an ultrasound scanner, allowing you to do field medical care and, you know, do an awful lot more enhanced diagnostic processes without the need for traditional kind of hospitalized infrastructure. Getting more fancier again, you know, this is a kind of blood glucose meter, and it can attach to your mobile phone, use the processing power of your phone and measure your blood sugar levels. Great for diabetics, and allows kind of more people to take personal care of their health in more locations around the world. Getting even fancier again, there's concepts around DNA and DNA analysis. So this is a concept that came out a few years ago for a DNA analyzer, allowing you to measure human or any sort of DNA genome powered by your mobile phone. So huge amounts of high-end technology condensed into this low price, low cost kind of hardware package that can be sent easily, can be brought with you, and can be kind of spread around the world. And then you can only imagine what you could do within your pocket DNA analysis. You could do a huge whole amount of stuff. But it's also lower tech interventions. So this guy here, Professor Manu Prakash, is a professor based in the US, and he created a concept called the paper microscope, which I think is an amazing kind of innovation. So they created this paper sheet, and from this paper sheet, it allowed you to create something called a foldoscope, a small field-ready pocket-based microscope that will allow you to do field analysis anywhere in the world for, I think it was a couple of dollars in total. So, you know, huge amounts of impact can be gained from something that is very, very low tech in price, but very, very high tech in application. Another one that's that I really, really kind of think is super cool is the idea of the soap pen. So the soap pen was created a few years ago to help hygiene and health in Asian countries. Basically what it did was a huge amount of illness is caused by lack of basic hygiene, and the soap pen turned it into a game for kids. Color your hands in with the colored soap to make sure the soap gets everywhere on your hands, and then wash it off. So super kind of low cost but high impact innovations that come from any and all kind of fields in general. So one of the ones that I do an awful lot of work with is based around 3D printing. So, and originally these kind of Ultimaker original wooden printers were about €1,500. You can now buy low cost 3D printers like the one behind me for like €150 delivered to you anywhere in the world, and you can do a huge amount of things with them. So 3D printing is ubiquitous in medicine for high-end healthcare, you know, 3D printed titanium kind of hips and joints, but you can also have as much an impact with low-end interventions. So things like cleverly designed braces and casts to help skin underneath casts in general, to make custom fit medical equipment. You can do a huge amount with these low-tech things. One of my favorite examples is a kit of surgical tools that were 3D printed in the field. I think it was in Africa. And it allows you to replace what would be a couple of hundred or €1,000 worth of, like, you know, surgical steel instruments, and create on-demand, low-cost, easily manufacturable 3D printed surgical tools as well in rural locations when you need them. No point keeping stock in them if you don't need them. You make it when you need it, and then you've got a huge kind of logistics improvement in there. Similarly, low-cost stethoscopes, again, using plastic tubing and 3D printed connectors. Low-cost, high-impact, very kind of creative and innovative use of these, what is high-end technology, but that's available at a low kind of cost price. So one of the most ubiquitous 3D printed objects in the world are Invisalign kind of braces. So Invisalign denture braces are the most 3D printed object in the whole world. You scan your teeth, send them away, 3D printed by an external company, posted to you. You've got your new fancy high-end 3D printed braces. So again, fancy technology, but used for kind of what is a low cost but high impact activity. And one of my favorite and what's close to my heart is 3D printed prosthetic hands. So projects like the Enable project that develops open source software and plans that allow people to share kind of designs for what is low cost 3D printed prosthetics. So, you know, a prosthetic that might have cost a couple of €1,000 can now be printed for €50. So shared online, manufactured in the field, created, and it can adapt and evolve with the user and the individual. So high impact, low cost. So that's a nice segue into the work that we do with the Rapid Foundation. So we set it up a few years ago, 2014, when we were working in UCD and had access to a huge amount of 3D printers that weren't being used to their fullest extent. We said these have more potential and we could do more with these if we allow other people access to them, and we'd show other people what they could do with them. So we approached a lot of NGOs, I think it was 2014, and asked them what were their 3D printing activities, and they didn't really have any. So, you know, we were thinking, what could we do if we had our hardware in a classroom like this in Uganda or Rwanda? What could happen? So Shane and myself, we set up the Rapid Foundation, and we'd sent our 3D printers overseas, and we have been doing ever since. So orphanages in India, you know, environmental waste collection facilities in Kenya, places in South America, Southeast Asia, sending our 3D printers with training, with traveling aid groups, and showing people what they could do with them, and just asking them, use them wherever you need to do. So the kids in India were making maps of India to teach geography. We've manufactured kind of leg braces and like casts for people that need prosthetics, and we've printed kind of low-cost prosthetic hands. Again, with a machine that costs 100, 200 euros, you can have a huge amount of impact. One of our latest projects was our project in Kenya, and this was in a place called Watamu in coastal Kenya. And we sent some of our hardware out to them, and we have a group of kind of young Kenyan girls working with us there that are looking at how they can use 3D printers to recycle the collected waste plastic they pull off the beach to turn into sellable commodities and assets for people to kind of improve the financial well-being of everything in the town. You know, all centered around this kind of 200 euro 3D printer, and just showing people how to use it and leaving them at it. And again, we do the same here with kind of public engagement activities, just showing people how interesting and cool it is, because we need new ideas, and anyone's ideas is as valid as anyone else's. And we kind of used to 3D print prosthetic hands here in Ireland, and it allowed us again to have a very, very big impact into an individual's life using these kind of low-cost technologies. But this also necessitates a change in how people think, and like the kind of future of education. The world is currently in its world's biggest ever education and work from home experiment to see how you can adapt in-person delivery to kind of remote work. So that's kind of some of the stuff we do with Sapien. So with that, we've looked at new sources of ideas. So here's a project we worked on to try and simplify the 3D printed prosthetics and make it out of paper. So we work with students to try and make paper-based 3D printed prosthetics to see, could we send it in an envelope, send somebody a hand in an envelope. You know, looked at different designs, different prototypes, different images to see what you could do with it. But an awful lot of the work we do is based on new kind of ideas. So crowdsourcing, hackathons, open access, open source, that sort of stuff. So we run an awful lot of hackathons with people. And if you've never done one, it's just a kind of focused developmental session over a couple of hours to a couple of days in which people come together, create new ideas, kind of work them and try to develop them as far as they can over the course of X number of hours, just to kind of accelerate that innovation process and show people that it doesn't have to be it's not as difficult as they might think it is to create these new impactful ideas on very, very short time frames. So, you know, whether it's a week, whether it's a couple of days, the process is still the same. You decide what you want to do, you set a target, you try and develop a number of different solutions, you decide which one is the best, you build a realistic prototype, and then you test it to see if it works. And you do that on an iterative basis to create these new sorts of innovations and ideas. So we've just finished two big ones in particular. One of them was with the European Commission, called EU versus Virus, and that ran as the European Commission's response to coronavirus. And over the course of, I think, a couple of weeks, we had 20,000 registrations. They created 2,000 plus new ideas. There was 600 partners, 50 different nationalities, a huge project, which we think was probably one of the world's biggest ever hackathons. And it created this huge content of new solutions, new ideas, but then also collaboration between companies, industries, countries. I think there's more than just creating the solutions when you run these things. We've just finished as well supporting an MIT one, which was the MIT's response to the same thing, in which they gathered healthcare companies to try and make more medicalized interventions. And again, they created, I think, 200 plus different interventions and solutions that have now been tested and validated as a response to kind of COVID going forward. And they're enjoyable. They honestly are really enjoyable. So here's one we ran last year with Singapore Institute of Technology. We had 150 students come over creating new healthcare interventions from Singapore. We ran the same thing this year with Tangent in Trinity, and it was remote. So we did the same thing via Zoom, all online. It worked as well as anything. They created new ideas. It was excellent. These are fun, these are enjoyable, these are interesting, but they're a new source of ideas. These aren't engineers. These were kind of healthcare workers. This was one with EIT, with the HSE, and it was generating healthcare interventions. And again, as you can see, it's very engaged, it's very bright, it's very active. This is the new form of innovation. People love this process. It's not engineers locked in a basement developing new solutions and interventions. And it's something that we're very keen to do, is involve other people, non-standard. So you could assume innovation is an engineer or an inventor or a scientist. It's everybody, you know, kids, the general public. So all our events are trying to be bright, encouraging, engaging, just to kind of get these ideas. All ideas are good ideas. Doesn't matter where they come from. This little guy here, you know, was creating paper models of 3D printed prosthetic hands. Who knows what he's going to do in the future, what ideas he has. But now he thinks he can, rightly so, that he can play a part in innovation into the future. He's done it in his mind, and he's more open to like expressing his ideas going forward. So as you can see, very interesting, very engaged, very open, lots of color, lots of movement, lots of activity. This to me is innovation of the future. This is what people love. They enjoy them. They feel welcome. They're encouraged to do them. And there's even one in there that we ran for EWB about a year or two ago on Facebook on the same thing, developing humanitarian interventions. So the final kind of story that I'll kind of end on is our activities based around Team OSV. So these are actual applied interventions. So I think it was Team OSV was our open source ventilator project that ballooned into developing solutions for a whole range of COVID-based interventions over the last kind of 3 months. So it started off very, very simply. Somebody had tagged me on Facebook. So tagged me on a post on Facebook and said, you should check out this group called, at that stage, it was called Open Source Ventilator, and it was on Facebook. So I did a little bit of promotion on it, and promoting it and encouraging people to join. It rustled up a body of people in Ireland that then wanted to respond. So a WhatsApp message or a Twitter post that I seen from a friend of mine, Colin Keogh. He runs an IoT company called WIA. And he said, what's the status of ventilators in Ireland? Do we need to start building something? This was about 2 days after I'd started to kind of set up an activity here in Ireland. So between him, myself, and David Pollard from Rehab Group, we had set up, at that stage, it was Open Source Ventilator Ireland. So as you can see, even with the times on the slides, the message went out. He posted his tweet at 12:21, and by 12:58, we'd had a group set up ready to roll, which was, you know, ad hoc, developed super quickly. And from then on, things just kind of went crazy. So we branched out into a load of different activities. Open Source Ventilator then became Team OSV, which was Open Source Volunteers, because we just didn't do ventilators, we did other things too. So over the course of the last 3 months, we had over 6,000 people fill in an expression of interest wanting to help from 139 countries around the world. And remember, this was people, there was no structure, no company, no order, no nothing. This was people that wanted to respond. It resulted in 3,924 active members in 2 individual Slack channels developing solutions. They sent near enough 100,000 messages to each other. It created a community of intervention and people that wanted to help, wanted to kind of help tackle COVID. So as you see, we covered most of the world, you know, every major continent, people committed to wanting to solve the problem, both locally and internationally. So our ventilator arm developed, I think it was 17 ventilator concepts over the space of about 6 weeks. You know, they were refined, some of them are dropped, some were retired. It created this huge new body of knowledge when it came to open source ventilator systems. Our other channel, OSVX, which was OSV Extended, they were looking at other interventions, so trying to solve other problems. And they worked with a range of problems, some of which you can see here. They developed and connected face shields and produced thousands of face shields. They provided guidance on face mask usage. They were looking at decontamination, airway support, isolation gowns, DIY printed, do-it-yourself and kind of maker-based medical interventions. So they worked tirelessly on that and created loads of solutions and made a huge amount of impact, you know, via engaging content like you can see here. They created educational content on how you wear masks and how you keep yourself safe. They manufactured face shields, visors, guides, instructions. And then one of the third arm of what we did was Bravo Charlie Tango, which was our biker group. And our biker group have been tirelessly delivering PPE for the last 3 months. If you had some to donate, you logged it on a system, a biker arrived to collect it and delivered it to a hospital, a healthcare provider, a nursing home, whoever needed it. And they have done thousands of deliveries of hundreds of thousands of pieces of PPE, all ad hoc, all started from a innocuous Facebook post. So, you know what I mean? All of that information is put in a website and it's now been tied up to provide information for others kind of going forward. So this is all well and good, lots of different things, but it's not all. There's some problems when you do interventions like this you have to kind of be aware of. So the first one is ethics. Should you be doing them? Are you safe? Are you qualified to do them? how are you going to impact supply chains? Are you going to offer false hope? So you need to make sure you ethically consider all of your applied interventions before you do them to make sure you're not causing more harm than good. There's legal issues about regulation, liability. We spent a huge amount of our time looking at, medical device regulation and liability for manufacturers. Legal counsel and support is available and offered, so make sure you're legally covered and you as an individual or your organization don't fall foul of these rules. Funding, you want to make sure it's funded. So all of our open source ventilator activity, we took in no funding at all from the beginning, despite the fact that we were offered significant amounts of funding from all around the world. We decided we didn't want to do that. It was to develop solutions and interventions for COVID only. We did not take any funding. Everything we developed was open source and free from the beginning. So if you need funding, you need to plan for it. And then you've got conflict. Take COVID. It was a stressful time for everyone. Conflict happens. Some people want to do this, some want to do that. And if you're penetrating or kind of disrupting previous industries, those industries don't like it. You know what I mean? It's going to cause some friction. So you need to be ready for it. You need to be honest and open about what you're kind of going to do and follow it through there. So they're just the kind of some stories about like how we've used technology in some of the projects I've worked on in the past, and kind of some of the tips that might help you if you want to tackle one of these kind of grand challenges. So that is me. Thank you very much. I wonder, do we have any questions?
Thanks very much, Colin. That was brilliant. So interesting to see all the different applications you've been working on. I particularly love looking at can you do the paper 3D printed prosthetics? It's fantastic. You'll have to keep us posted. Where does that stand at the moment? Actually, like what was kind of like
that was an amazing designer, Anya, that I worked with. It was her master's project, I think, and she did an amazing job, and we were kind of getting at we were very, very close to the stage of being able to create a flat pack paper prosthetic hand. So close that we were into the operational problems of what happened if it got wet and that sort of stuff. But that was a good example. When we brought that to prosthetists, they were like, "Oh, it's going to get wet in the rain. That's a terrible idea." It's like, yes, but it costs. I think the cost on it was like 50 cents. If it gets wet, we'll give you another one. No big deal.
When it's not
different mindsets.
Exactly, how you overcome the problems. Okay, we've got a couple of questions here now. We'll start off with one, or actually, sorry, I'll unmute Brendan Heary. Have a chat with you. Okay, Brendan, I'll just come up to you now. Okay, Brendan, you ready to go there?
Yeah, sorry, I was already talking. I thought it was unmuted.
Oh, sorry, it takes me a moment to unmute people. Apologies.
Yeah, thanks for the presentation, Colin. I was just wondering about the Ventilator Project. Did anything come of it? Did any of the prototypes get accepted by hospital or anybody?
So yeah, it's a good question. I should have covered that in. So they did around the world, but it was a very, very strange situation. So what happened was when we started it at the beginning, it was the world's biggest problem. Everyone wanted these ventilators. It was the only thing anyone was talking about was to create ventilators. And our own work and other teams were led astray by poor regulation at the beginning. So what happened was we had 3 active concepts that underwent testing with teams in the US. So the 3 concepts were prototyped, they were testing, and they were in operation in hospitals, not on people, but in a kind of medicalized testing setting to make sure they could meet the minimum base requirements. And then suddenly overnight, the requirement from them just disappeared. That's the kind of like all of the hospital groups and all of the interest overnight, people were like, we don't need these ventilators anymore. So it was just kind of, all of the motivation went away. So all of our ones, they got as far as like pre-FDA approval. So there was exceptional use authorization granted to a couple of other designs in the US, but it got just to that level. But without the requirement for them, we didn't see a point in kind of achieving the certification when there were already some that were certified for use already. So we just decided we're in a process now of repackaging the designs to give kind of as much information as we can safely to other people if they then need to replicate them in the future, or we have a huge second wave or something of that sort. So they got the kind of pre-authorization phase, and then regulation, logistics, and kind of legal got in the way.
Okay, cool. Thanks.
Thank you.
Thanks, Brendan. I'll just put you back to mute there now, and then move to, we have one more. Sorry, Brendan, just need to, there you go. Now we have one from, okay, someone anonymous, so they don't want to, so that's grand, I'll just read it out. So, how do you create buy-in from people who think design thinking is a waste of time?
I
So,
relate. Like, yeah, to give you framing on that, I undertook my PhD under that belief that design thinking was a waste of time. But it's not, in effect. So, like, to get buy-in from them, when it comes to design thinking or any sort of these led innovation workshops, the caliber and the quality of the person that leads the workshop is 90% of the success of the workshop. You know, if you get somebody who is passionate about it and has actually used it in the real world, you know, they might not have like used the design thinking process, but really good field innovation follows that order anyway, naturally. So if you have a really good person delivering your content who has done this stuff in person, you can you pull from stories, you pull from experience, and then it makes it real. So, you know what I mean? Design thinking is a great process. It is an amazing process, but it lives or dies based on the strength of the facilitator that delivers it. And unfortunately, there are an awful lot of kind of waste of time facilitators that aren't very good at it. You can have read it from a book all you want, but if you have not done it, if you have not had ideation failure, if you've not had your ideas, you know, you sink months of effort into something and it gets evaporated with one question. If you've not been through that process, it kind of, when you get into the weeds, that's where the kind of uncertainty about the process kind of happens. It's like any process used well and used by people who know what they're doing will succeed. But I think that's the problem design thinking has is it's just an awful lot of people don't really understand the process of innovation well enough to deliver it successfully. Yeah. So it's kind of, it depends on your facilitator. So yeah, if you want to convince somebody, get them to a really well-run workshop on design thinking and to see what can come from it, to see the quality of ideas and the speed of iteration and that sort of stuff. So that's what I would say.
Brilliant. Thanks, Colin. We've one now from Chris McCallum, I think it was. So I'll just allow him to talk there. Chris, if you want to go ahead.
I think he's still nodding.
There we go. That should be me now. Great talk. I was just wondering, with the move to virtual at the minute, how do you get experts who would be slightly older, who may not be on these social media platforms, to engage with this then?
So with these sorts of projects, or
with these sorts of projects and with design style thinking and everything at the minute, just people who may be experts in the area who wouldn't hear the call go out.
Yeah.
If it's on those kind of platforms, and then drawing them in to let them know that it's important, and you know you've got people behind it already.
Yeah. So like it's that's a really good question actually. So the first thing I'd say is you're 100% right that there'll be a load of people that are experts in that area that won't be on these platforms, but you'd be surprised at how many were. Like an awful lot of our advisors came from locations you would never expect. So one, you'd be surprised, but then two is use the traditional approaches. Once you've built up the momentum behind something, so something we did with the Ventilator Project very intentionally at the beginning was when we'd started it, we were trying to tackle what was one of the biggest problems in the world at that stage. So we went public with it. We did media, we sent press releases. Well, we didn't send press releases, but we had people come to us to say, can we interview you? Because it was a very buzzy question. So we did that at the beginning for a period of about 2 weeks, and then we stopped doing it. And the idea between that was it got the message out to the people that aren't on the platforms we were targeting. So traditional experts, traditional other things. And then they came to us via email, an awful lot of them sending in kind of cold emails saying, I read your article in the New York Times. I'd love to help you. I'm a respiratory specialist. Or, we had kind of, and even then, if you want somebody in particular, if you're doing good work and it's impactful, go and get them, find their email address and drop them an email, very professional, very above board, and say, look, here is what we're doing. Here is the momentum we've built up. Can you help us? So engagements like that work really, really well, but they kind of succeed on the strength of the individual. You know what I mean? If you're going to go down that, have one person do it, and have one person, you know, who's very kind of upstanding or is a professional in some shape or form, that if they do a little bit of digging on you and your activity, there's something there for them to kind of bank on. So, you know what I mean? If you need to engage these people in that are outside your normal engagement platforms, find whatever engagement platform they use and kind of go after them. So I know, like, we had people reference us to people, we had introductions to people, you know, I had phone calls, emails, that sort of stuff. We didn't have postal letters, thankfully, but anything and everything was their engagement metric. You know, people commenting on YouTube videos to say, I'd love to help, and then them sending a message that way. Any way you possibly can do it is the kind of the approach.
That's perfect. Thank you.
Thank you.
Great stuff. Thanks, Chris. We just have one now, actually, again, anonymous, so I'll read it out. The medical projects are great and an asset to society, but does the 3D printer not encourage the throwaway culture?
It does, 100%. So yeah, it's a good. It does encourage the throwaway culture, but what we've done is we combated it kind of on two ways. So the 3D printer is, again, how you use it. So as you can see, like as you can see, 3D printed gimmicks all over the place. You know, it's been used historically to 3D print little things, gimmicky things, which is all well and good. That's kind of what we wanted to change. So our 3D printers in our field locations, they are a tool, as I said, they're used for a specific function. So we empowered the individuals themselves to solve their own problems. So one, it means they have buy-in into the solution. So like the girls in Africa, they are cleaning their own beach and they're generating income for their own community. So they don't want to waste anything. They don't want to waste material. They don't want to waste anything. So meaningful impact with the projects can kind of reduce that throwaway culture. But then also, if you are encouraging it, you can then make plans to recover it. So like an awful lot of our projects, we have recycling built into them. You know, there's a circular economy principle underneath them. If you manufacture something, when you're bored with it, shred it back up again and process it into new material. So it's kind of all encompassing. You have to acknowledge that it's there, but when you present it to individuals in particular, you don't give them an option and just kind of say, look, you use this machine to make things that you need. And if you no longer need them, you recycle them into something else. So, you know, that's the kind of process we went about that way is, yeah, you have to kind of cut it off. It's so easy to manufacture things. You don't want people to manufacture throwaway nothingness. Yeah,
absolutely. Yeah, definitely having the circular economy principles underpinning it's very important, for sure. Is there any other questions there, guys? I don't see any at the moment, but give it maybe a moment or two more in case there are. But if not, look, just a huge thanks to Colin, and thanks very much, guys, for tuning in today. We do have one more, so oh, sorry, no, that's me not having dismissed the last question, so it's there. There may have been one last one from Chris, maybe very quickly before we finish off. Chris, did you want to have do you have a follow-up comment there, or is that okay?
Yeah, it's just creating, how do you engage with people who deem themselves then on the reverse of this not to be an expert, so to create buy-in from, as you say, from people. We've had it before where there is no engineer and people automatically assume it's for engineers. So how do you create buy-in from people who are class themselves as not an expert and could bring a lot to a project then?
A big challenge for an awful lot of this sort of stuff. So what we've found quite successful, and it works for us, it might not work for any other kind of project, is that's a kind of hard one. So one is kind of like that we try and involve them in our projects as the owners of the projects. So, you know, our facilities in Kenya, they're not ours. We've just donated to them. They're the local community's facility. It's for them. And for our kind of field workers, we found a kind of an elder of society, let's say, somebody that was respected and will take ownership of the kind of the hardware itself, and then it becomes the community's activity and not just ours. So, you know what I mean, we very intentionally try to distance ourselves from that. And what we did is, from one of our lessons, our first our project was in rural, it was a slum in India. It was in an age orphanage in India. And me and Shane are both engineers. We kind of completely erroneously thought we knew what people in a slum in India would want. We had no idea. So we'd sent it over, and very, very quickly it became clear that we would send it over for the wrong purpose. So we were just honest, and we said to the people there, look, we don't know what you need. Tell us what you need. Tell us what support you need. So involving the actual people as much as possible into it. And then that kind of happened via local connection. You know, you can't get away from personal connection. If you have one person that knows you or you know them in the area, an awful lot of those projects those issues get resolved, because then it might be me talking to somebody in Kenya who then will sort their local problems. So it's you want to make it as community focused as possible and try and involve as many people from that actual community as early as possible to kind of try and minimize them issues. But it's always a kind of challenge. Like you can never really beat being face to face in person with the people to build up them personal connections, but we have to try now, I guess, because we can't go.
No, that's great. Thank you.
Thank you.
Thanks, Chris. Brilliant. Well, yeah, thank you so much for that, Colin. It's a nice note to finish on as well, to do the importance of the community connection and keeping connection alive, and how we can adapt and do that now on the online world. But yeah, look, thanks a million, Colin. I'm delighted to have you with us today, and thanks everyone for tuning in. Just to mention that next week we're going to have Elaine Doyle, who's one of our EWB directors and also Coastal Programs Officer at Untashka, and she's going to be talking about litter, not always a waste. So that'll be next week. So it'll be a very interesting perspective from Elaine. So cheers, Colin, and thanks, guys. Have a good afternoon.